Hey YouTube, welcome back to the Blades to Be shop and another project video. I think I have a pretty interesting project for us today. The project itself is a height gauge for setting tool heights on the lathe. So it's something that I need. I don't want to always be turning my quick change tool post around and using my tailstock in the center to do that. So I just need to make a height gauge to do that. Seems like a relatively simple project, but I think we're going to have some pretty fun aspects of it. Because again, it's not about the project, it's about what we can learn on the way. So for this project, I'm going to use a combination of some 2-inch 4140, but I'm going to have that right up against the ways. I don't want my 4140 banging on that all the time, so we're going to put an aluminum base on that to make sure that we're, again, not dinging up the ways every time we use this tool. So again, we're going to have two parts putting together, so that's one interesting aspect of it. Also, we're going to put a swivel cap on the top of it, and that means we're going to have to drill and tap an off-center hole in the lathe. So we're going to practice using a 4-jaw chuck and a dead center to dial in that off-center punch mark that we're going to make to get that hole right where we want it. So that's another aspect. And then I'm going to put some knurling on the outside of it just to make sure we've got good grip as we're grabbing this and setting it down on the lathe. So again, it should be a pretty cool project with some different interesting aspects in making it, and it's definitely something that I need, so going to be a useful tool to have around the shop as well. A lot of lathe work on this one. Also going to notch it out a little bit on the bottom so that it comes over the carriage a little bit so that it gets up a little bit tighter. So that means we're going to go over to the mill and mill a notch out of the bottom of it as well. So good chance to use both tools. But we're going to start on the lathe. Let's head over there and take a look at where this is going to sit, what it's going to look like, and we'll take a look at the drawing so we get an idea of what it is we're making. Before that, hey, as always, thank you for watching the videos. If you like the channel, want to see more videos on machining, welding, everything else we're doing here in the Blades to Be shop, go ahead and hit that subscribe button, ring the bell, you'll know when the next video is coming out. Trying to get them out for you every week, typically by 7 a.m. on Saturday morning, sometimes even getting them out on Friday night. All right, let's head over to the lathe and let's get digging into this project. Come on. So first off, let's take a look at where this is going to go. So for me, if I set this right down here on the ways, then that's going to get to any of the tools I have on my quick change tool post. I'm able to back this up far enough, even if I have a tool on here the other way that sticks out a little bit. I've got plenty of room to check the height that way just by moving my cross feed back and forth. And for boring bars, they're going to be over the other way. So if I move over this way with a boring bar, then again, I'm going to be able to get in there and check the height on a boring bar as well. So I know I've seen lots of different designs. Some people put a bar across the carriage to be able to set this anywhere in between. But I think I can get to everything I need to by putting it down directly on those ways and just eliminates one extra piece. But as I mentioned, putting some hardened 4140 on and off of there, I don't want to do that. That's why we're going to go ahead and put an aluminum bottom on this. So it's actually going to be a piece of aluminum that's going on there. And it's 2-inch and it's hanging off the back there quite a bit. Pretty good overhang. So that's why we're going to cut a notch out so that it fits over top of the carriage and we get a little bit more surface area right on top of the way. So that is the overall design. Let me spin the camera around. Let's take a look at the drawing and talk through our order of operations and how I think this is going to come together. Alright, so here's a better look at the project and what we're going to put together. I mentioned order of operations, and I did try to put together my order of operations for a couple of reasons, a couple things I was trying to accomplish. I didn't want to end up with a center drill mark in the top of my cap. I didn't want to end up with a center drill mark in the top of my piece, and I did not want to have to grab onto this knurl portion. Even with shims or anything else, it's still going to put some squish on your knurl and interfere with that, push that down. So I tried to make sure that I had an order of operations where I wouldn't have to do those things, where I wouldn't be grabbing that knurl in the vise. So I saved the knurling for last. I've got my center drill hole down here at the end. So here's what we're putting together. We're basically taking a piece of this 4140, this 2-inch 4140. That's what's going to take up our main body and make the cap. We're going to marry that up with a piece of this 2-inch aluminum. So we're going to have a 1 3/4 inch piece of aluminum on the bottom here. We have to cut the notch out of that so that it fits around the carriage a little bit and sits nicely right there on the ways. Overall height on those two pieces should be right at about 7.1 inches. That's what I've roughly measured it. Once I get this 3-jaw chuck off, but when we're transitioning to the 4-jaw, then I will put in the dead center into the headstock and we'll take a more accurate reading and make sure that we have the exact measurement on that one. So what we're going to do is we're going to drill and tap this piece of aluminum, 1/2 inch course. I'm actually just going to turn it down on the 4140 and thread that for the 1/2 inch to go together. But I'm going to epoxy these pieces together solid. So this is not going to be height adjustable. I've seen some other ones where they are height adjustable. I plan to only use this on this lathe, so it's not going to be height adjustable in here. It's a one-shot deal. We're going to need to make sure we face it to the correct length the first time, or we'll be getting creative with putting a spacer or something on it if we mess that part up. So hopefully we don't do that. Hopefully we get it right first time around. So we'll go through and from an order. We're going to drill and tap the piece of aluminum. We're going to face and turn down the thread on this piece of 4140. It's kind of a long piece. Then we're going to lock these two together and epoxy them together. Once that epoxy has set, then we will cut this piece of aluminum in the saw. We'll cut off most of that. We will face that and center drill it. Then we're going to pull it all out of the chuck, and we're going to turn the full OD on this. So that's going to be turning the OD of the aluminum, the 4140 body, and the cap, and the material we're going to need in there to part it off and clean all that up. So that's going to be a total of 7 5/8 we're going to turn for the OD. Then we will go out in the saw. We'll cut off the excess 4140 that we were holding on to turn that. At that point, we're going to grab it in our forejaw, and we're going to grab in this area that we're going to knurl right here, because then we don't even need to use shims. Any marks we put on there, the knurling should take care of that afterwards. So we'll grab that in the forejaw, and we're going to face off this end, and then we're going to mark that off-center hole, which is this one right here. We're going to mark that off-center hole, and this is where we're going to get kind of fun. We're going to use the forejaw. We're going to dial that in. We're going to use a dead center to hold into our punch mark to dial that, to get that accurately offset. And then we're going to drill that, tap it, use a couple of end mills to go in there and put the through 1/4 inch hole, and then put our 7/16 counter bore in that. So we'll get all those operations done on the cap, and then we will dial it back into zeroed in again, and then we will part that off. After we have that parted off, then we will face this to our accurate length, and we'll clean up the backside of this cap, and we'll face that off. And at that point, then we will take it over to the mill. So we still haven't knurled it yet. We can grab this whole piece in the mill. We'll mill out this notch down here, and then our last step, we'll bring it back to the lathe, and we will use shims. Then we'll be grabbing down here at this end. We will put some shims to make sure that we're not putting any marks on it. We've got our center drill down here, and then we will knurl that 3-inch piece in the middle. I just have the knurling tool that came with my CXA tool set. I have put some new knurls on it, but still, it's not a quality knurling tool by any means. So if we don't have good luck knurling this the first time, if it doesn't look good, then hey, we're going to just machine that down, and then it'll just be like a necked in hourglass figure, like we did it on purpose, until we get a good looking knurl in there. So that's the beauty, the fun part about making parts that don't have critical sizes to them is, you know, if it doesn't turn out exactly perfect the first time, you get to add some artistic interpretation and make it look the way that you want to. So really the only critical size we need to hit on this is this overall length, since it is a height adjustment gauge. We want to hit that. Most of these other dimensions on here, we're just going to make sure we get them looking good and looking the way we want to. So that's our overall order of operations, to make sure we minimize where our extra marks are and make sure we're taking care of the surface finishes. Just because it's a cosmetic part, that's really all it is, and we're going to try to make it look as good as we can. So that's the thought. All right, let's go ahead and get lined up in the lathe, and let's get this piece of aluminum in there, and let's get this drilled and tapped for step number 1. Alright, tap drill size for 1/2 inch course, 27/64. We'll get that pushed in there. We're going for 1 inch deep overall, so I'm going to go just a little more than 1 inch. We'll probably end up not quite putting a full inch of thread on our other piece to get that together. We'll drill just a little over 1 inch deep, and we'll tap as deep as we can. And here's my tap handle from Northern Machining Incorporated up in New Jersey. So it's nice, it's got a little cam lock on the back, so it self-centers your tap in there. And then after you get that centered, you still can tighten up your other pieces here to lock that in. And we've got a bearing on the back side of that. So we're going to grab that bearing in our chuck, and that's going to allow me to spin the tap with both hands. It makes it a little bit easier to get in there and hand tap this hole. Makes it really nice for hand tapping a hole. Alright, we're running into some chips in there. Pull it out, get some air on it, get it out of here, and we'll finish hand tapping it in the vise over there, because that's it. That's all we're doing for this step, was we just needed to tap that hole. And we can run our tap back down there in the vise and just make sure we're in there as deep as we can. And then we're going to run some threaded rod in there to find out how deep we're going to have actual threads, and then we'll know how far to thread our other mating piece. Okay, I put it in the vise. I got an extra couple of turns out of the tap. So we got that cleaned out. I put some air to it. We've blown that out. Let's see how far we are getting our rod down in there. All right, so right about where that ends. So that's our line right there. So we've only got about 3/4 of an inch of thread that we're gonna get down in there, unless we bevel our end on ours a little bit more. So we're looking at about 3/4 of an inch is what we can go for as we thread our other piece. We'll get our mating piece in here. All right, we're turning this one at about 750 RPM on this 4140. We've got enough sticking out. We're gonna machine that back to 1/2 inch, go back 3/4 of an inch down to 1/2 inch diameter, and we're gonna cut our thread on there. I know I cut one the other day. Originally, I was gonna use a piece of just threaded rod between these two parts, so I was just gonna drill and tap this. But then I thought, what the heck, we can go ahead and do that. I know that I can turn up to a pretty tight shoulder. I'll get in there and I'll just have to notch out the back side of that a little bit to make sure that our pieces go right together, but there's no need to use threaded rod, or we can cut a 1/2 inch thread on that. So let's knock that out. Alright, so that's as close as I can get to get rid of that last little bit at the end of the shaft there before the thread. So we will just have to make sure we've got enough of a bevel on our piece of aluminum that it's going to go in there and it's going to go right up flush all the way in there. Alright, let's get this set up to thread 13 threads per inch. 13 threads per inch, I'm going to spin that at 130 RPM, and we're going to stop in that little groove right there. 13 threads, we're going almost right at 100 thou deep, and on my outside diameter, this is pretty much cooled down now. We should be just 2 or 3 under. We're only 1 under. It's all right, we'll hit it with some emery cloth as we get some threads on there. Or I'll just knock that down with the emery cloth a little bit right now, and then we'll get that threaded. Nice snug fit, that's what we're looking for. Let's make sure this is going to fit together for us and spin all the way up there flush. And yes, we are on there tight and flush. Alright, let's get these out of here. Let's get some epoxy mixed up. We'll get some acetone on these, get these all cleaned up, and let's get these two parts epoxied together. Alright, I could probably just use Loctite on this, but hey, I want something permanent. I do not want these pieces coming apart. So we're going to go ahead and mix up some epoxy. This is 24-hour epoxy, so this will be the last thing we do tonight. But first, let's get our parts cleaned with some acetone. Make sure we have all of our cutting oil, everything off of these parts. There we go, our part should be nice and clean, and by the time we get our epoxy mixed up, all that acetone will have evaporated out of there. So I'm going to get one part mounted in the vise here, and let's get our epoxy mixed up. Again, I do epoxy by weight, that way you're not trying to eyeball mixing up your two parts, just a lot easier to do it that way. Alright, let me get the camera turned around, let's get this epoxied together. There, we got that nice and tight there now. Let that cure till tomorrow. We'll come back and we will get to work on our next step. That's it for tonight. We'll see you tomorrow. Alright, our piece is epoxied together, and that is ready to get machined, cleaned up. So now next step, we're going to take this out to the saw. We're going to cut this down to length. Grab a hold of this in the lathe, face this end off, get that to, pretty much our 1 3/4 inch length, as well as we can measure it up to that shoulder. So we'll get that faced off, and then we'll center drill it, and then once we have that done, we'll take it out, and then we're going to cut off our other end here to length. We need to make sure we're leaving all the length that we need on that. We'll get that cut off, and then we're going to get that back in the lathe. We'll face that off enough to clean it up. We'll mark our off-center bore, and we'll start working through the steps that way. Let's get this in the saw, get it cut off, faced off in the lathe, and then we'll pick up on the next step. Yeah, when it's taking an hour to cut aluminum, it's time to change the blade. Look at that sucker go now. Alright, we're looking at almost 93 thou to come off of there. Let's get that faced off and then we'll check. And also, it's a good thing we write down our order of operations, because we're going to face this off and then we're going to turn the OD on the whole length. So we got to do all that before we turn it around and cut that 4140 to length. So face this off, center drill it, and then we're going to pull that out and we're going to turn down our full 7.5 inches or so that we're going to need total. And then we'll pull it out and start working on that cap end after that. So about 45 thou to go. It cuts nice on a heavy cut, so we're just going to take all of that at one time. The overall length was where it's going to be critical. Getting this, the 1 3/4 was just kind of a made up size, so that'll be perfect. Now we'll get that center drilled. Okay, we're turning 7 5/8, somewhere right around there. Alright, so the reason we're going 7 5/8 is because we have our 1 3/4 here. Let's get our picture. Alright, we've got the 1 3/4 for the aluminum. We've got 5.35 for our finished 4140. We've got the 3/8 on top, and we're going to have to part that off right there to separate the cap, and we need a little bit of room at the end to face it off. So that's why we're going with our 7.1 plus 3/8 plus 1/8 of an inch to part plus a little bit of room. So that's where I came up with the 7 5/8, just to make sure we have enough, so we don't run out of material. So that's our 7 5/8. So we're going to turn that back. Again, we're not hitting a specific size. It's currently 2 inches. I think if I take a 30 thou cut off of there, that's going to be enough to get a decent finish on this at a good speed. Got a pretty decent rate of feed, so I just want to take one pass off of that so that it cleans up nicely and we get a good finish. I think that's a pretty fresh insert on there still. So that's the goal. Take one 30 thou pass, clean everything up, get a nice finish, and then we are ready to work on to our next step. So I'm going to turn this at, normally I'm turning this at 750 for this 2-inch 4140, but since I'm only taking one cut at 30 thou, a little lighter than normal, I'm going to go ahead and turn it at 900. Should be sort of a good compromise between the aluminum and the 4140, and I'm feeding at 7 thou per revolution, so I think with that fresh insert on there, that should give me a nice decent finish with that. So that's the goal. Let's give her a shot. That gave us a nice respectable finish across there. We're going to put knurl for that 3-inch chunk in the middle, so that's going to change that up some too. But yes, that looks good. Let's put a bevel on there and let's get this out of here. I think that turned out all right. Looks kind of cool, that transition from the aluminum there to the 4140. That should be a good looking part when we're done. Alright, let's get this back out in the bandsaw and let's cut off the rest of that 4140. Now that we've got a nice sharp blade on that bandsaw, should make short work of getting rid of that, so that should be good. Feels good. There it is. Alright, let's get this cleaned up a little bit. Get that 3-jaw chuck off of there. Let's get a good measurement of exactly where our center line is off of these ways. So we'll get a good measurement off of that with putting in our adapter sleeve and put in a dead center. And then we'll get our 4-jaw on and we can continue on with this process of making our cover plate and get that parted off. Well, there we go. That is going to give us our accurate height measurement. I'm not going to be able to measure down to the ways, of course. My plan is I'm going to lock in one of these big flat carbides. We are going to get this lined up on center, and then I'll come over here with my vernier and we'll measure down, and that will be what we're going to go with. I know putting a dial across, some measuring blocks, some other things would probably get me closer. But honestly, I think for what we're looking for here, this is going to accomplish it for me here. All right, I'm liking that. I am getting right at 180 millimeters. I'm sure 180 millimeters is what it is. 7.087. Let's do the math calculation on 180 and see what that gives us. So 180 millimeters is 7.0866. Well, I got 7.087 and 180 millimeters. I would say we are tracking all right there. I like it. 180 millimeters, 7.087 is what we're going for. Write that down before we forget. I got it the same again a second time, so it doesn't hurt to double check. After I tightened that up, it was sitting high, but it was just because it didn't drop on there exactly right. So we're good, 180 millimeters. Let's move on to our next step. Get that 4-jaw on there. That's right, I don't need shims this time around because my jaws are less than 3 inch. Let's just mark on that where the knurling is going to be and we'll make sure we're grabbing in that section. Alright, so it's going to be knurled all in between right there. So if I grab that, even if we leave a little bit of jaw marks, the knurling should take all of those out. Alright, so we got that within 15 thou. Alright, that's within a couple of tenths. All we're doing is facing this off. That is plenty good for right now. Rub a little emery on that. That is going to be our finished top of the cap there once we're done. There we go. Now, all that dialing just to take that one little cut. Now we're going to pull that out of there and we are going to barely take that edge off of that as well. So we're going to be measuring out to that. All right, so we're going to pull that back out. We are going to mark our offset hole. We're coming 5/8 off the center. So we just need to be 5/8 off that center line. And then we are going to dial in that hole using a dead center. So we'll come back and do that here in a minute. And we're going to dial this offset so that we can drill, tap, and counterbore that hole all through both pieces. Then we'll come back, dial it back in, and we'll part that piece off. And then we should have a cap that is going to match up and fit nicely on there when it's all done. And then we'll be doing our precision cut, which is facing that to length. So let's get this back out of here and get our hole marked. Yeah, not too bad for jaw marks at all. Definitely our knurling is going to get rid of anything that we are going to do there, so that's going to be fine. All right, let's go over to the bench and let's mark our hole on here. All right, I want to measure, make sure I'm measuring more or less a straight line. It's only one hole, so we shouldn't be able to get too far off the track here. I'm going to set these for 5/8. And I'm going to use those to set my dividers. We're going to measure off of that center mark right there. And yes, I can see my mark right there. There we go. See it better if I do it that way. Perfect. Love this bullseye center punch from Grizzly. And there we have our punch mark in there. Double check that. Yes, there we go, right back to the center. So we're 5/8 off center. Now we're gonna go dial that in on the lathe and get that drilled. All right, well first we're gonna try and make things a little bit easy for ourselves in that we are going to back one of these jaws off, 125 thou. And that'll give us our, except I need to go 625 thou, so I'm not sure what I'm thinking there. It's 125. It should give us a reasonable starting point. So I need to line up my piece 180 to that. Now I'm so spoiled on this lathe with everything going straight through the spindle that I was kind of thinking that was going to happen. I was forgetting that once this is offset, I am not going to be able to make it through the spindle anymore. So that is not going to happen, which means we're going to want to put some shims in there so we don't mark up our aluminum all over the place here. All right, let's kind of hold that there while I put some shims under it, and then we'll see where we are. Well, let's see how this is going to work. All right, we're within a couple thou there. Let's see how we are doing for having it straight in the chuck. We're actually only off by maybe just right around 2 thou. Let me grab a brass punch here. That moved a little bit that time. All right, we're off about 1 thou. I think that is going to be fine. Let's finish getting this dialed in for us here. Okay, sometimes you just gotta say good enough. We're drilling a hole and tapping it. We're 2 thou on run out. We're 2 thou for being straight. Actually, we're only about 1.5 thou or so on run out. I think that that is close enough for our drilled and tapped hole. So let's go ahead and get that done. Let's see how it looks when we turn it on. All right, we're gonna turn it relatively slow here. So 250 RPM. And our center spot is turning right where we want it. That is almost hard to look at, you know, but that's all right. That is working. Get our hole drilled in there. All right, so we're going to drill our tap drill size in there first. And since this got a little long for our cap and everything, let's figure out how deep we need to drill in here. So I'm going to end up at 7.1, and I want to be drilled and tapped in there 3/4 of an inch from there. I'm not going to have too much to face off of there, that's for sure. Well, I guess there's a lot more there than I think. I'm only going for 375 for the cap. So yes, I'm going for 375. So we're going to face some off of that, and that's still going to leave us with enough to part and enough to face off when we're done. So, okay, we have plenty of material. We're doing fine there. Bevel off those marks I made with my brass hammer there. All right, so from here, if I want to be 3/4 of an inch deep, and I need to drill in roughly. I want to be able to tap 3/4, so we're in about 1.5 inches. Whew, that is interesting watching that go around. All right, now I need that to be all the way through 1/4 of an inch, or I need it to be 1/4 of an inch hole all the way through the full 3/8 deep. All right, we've got room, so I'm going to do everything that I do here. I'm going to go an extra 50 thou, because then I'm going to be able to take 50 thou off of the end here, get rid of any of the marks that I made. So I need to go in 3/8 plus another 50, and I can go a little extra because it's just where it's going to get parted off. All right, so there's 425 deep with my 1/4 inch. Then I need to counterbore that 7/16 of an inch. I'm going 1/8 deep with this. I need to go that extra 50, so I'm going to go 175. All right, we got about another 40 thou to go. Well, it's an angle. It's not going to read perfect, but it'll give me an idea. There we go. Let me feed a little faster, and that's what that end mill liked. It liked a little more feed. It did not like rattling around on there loose. All right, let's see how we did for depth. Maybe about 5 thou deep, but that we fine. Well, there we are, drilled through counterboard. So our screw is going to fit in there nicely. Let's get our tap. Let's make sure we get our tap started in there square, and then we will get this piece lined back up and part that off. All right, we got that started in there straight. So that will do. We'll finish tapping that when we get it back out of there. But that's pretty much it. So now we're going to pull our piece back, drop it back in the chuck, grab it back here where we can easily grab it where we're going to knurl it later. And we'll get that lined up. We'll face off our 50 thou to clean up any marks we made. We'll part off our cap there at 3/8 of an inch. Put a nice bevel on both sides of that, and then we will be ready to face this to overall length. So there's how you counterbore or set something up off center using your dead center to dial it in. I would say that worked all right for you. You know, every once in a while you just get lucky in that we made this a little over 1/8 of an inch deep, and it is actually supposed to be 1/4 of an inch deep. So 1/8 of an inch is only the head of this screw, and when you put the head and the washer together, it's 1/4 of an inch deep, and I wrote that down wrong on my drawing, just measuring the head. So thankfully I hadn't taken this out of here last night, so slept on it, and it's still in here and set up. So we're going to go ahead and punch that another 1/8 of an inch deeper. And now that we know a little extra feed on that end mill, it doesn't want to chatter, it cuts pretty decent, we should be able to do that fairly quickly. So we're going to do that. And also, hey, before we take this out of here, just thinking about the setup and why we were having such a challenge dialing that in with that dead center. And if you look in here at how this is set up on the chuck, we've got two of these jaws are so far down on the back side of our piece that it really just didn't want to move over. So just a little bit more complicated than normally dialing in a 4-jaw chuck, and I really had to loosen these two off in order to get it to move and get it lined up across, in this case, jaws 1 and 3 a lot better. And then even as I tightened 2 and 4, it wanted to sort of push it that way a little bit. So this much offset gives a little bit of different challenges, but other than that, it really dialed in exactly the same as any other time dialing in the 4-jaw. And we still got it within 2 thou and 2 thou across the length, so for the hole that we're making, still plenty accurate on there. Kind of a fun way to dial something in. So if you ever need to make an off-center bore, anything sort of cam related, using that dead center like that is a great way to dial that in. All right, well, let's get this turned back on. Let's punch that counter bore in there 1/8 of an inch deeper, and then we are going to move this back, face that, part this off, clean up our end a little bit, pull it out, measure it, get it in there, and get it totally face to length. We'll be ready to mill our notch on the end, and we are getting close to wrapping this up. Let's keep moving through our steps. And that's simple. We were able to fix that, save it before we pulled off our setup. Worth 30 seconds right there. And we were about 5 thou deep before, if I remember right. That's why I went a couple thou less on that one. Yeah, we're a little deeper than we needed to be. But we're going to face some off of that when we turn this around, get rid of that mark we made. So we'll get that faced back to 1/4 of an inch deep. And then we'll get that parted off. Shims worked well. Not a mark on it. All right, let's get it pushed back in where it's going to be on top of our knurl marks. That is good enough to face this off. All right, we're going to face this off at a nice fast feed. Try and get a good finish on there. And we're taking 50 thou. I'm going to take that all in one cut. Nice heavy cut. Seems to clean up a little better on this. So let's take all of that once. Yes, even across that hole. That nice heavy feed gave us a good finish there. Okay, let's put a nice bevel on that. That's got that looking pretty. 0.375 plus 0.086. We're going 461. I'm going to leave myself a little bit so we can face about 20 thou off the back side of this. We're going to grab that and make sure we clean that up a little bit as well. That should give me enough to face that off right there. Now we're going to be facing through that hole, so it's going to go a little clunky on us, but I think it should still face off just fine. Well, that insert is not happy. Let's get a new one in there. Well, we'll get that back in there in a minute, face that off and clean it up, but there is our nice looking cap. Counterboard, drilled through, ready for the screw to go in that. We just need to clean up the backside a little bit. All right, let's measure our length on this. So I'm going to go get my calipers. We'll measure the length and then we'll come back and we will face this off to our finished length of 7.087 inches, 180 millimeters. We are almost exactly 1 millimeter long. So I am right at, it is just, we're going to do the calculation on exactly what's a millimeter. So on the inch vernier, I'm getting a reading of, here, let's get the light over here on it so I can really see. So again, on the metric side, I am right just perfectly at 181 millimeters. And on the inch side, I am at 7.1. Yeah, it's about 7.124. Wow, let's see, what does a millimeter come out to? Let's see what 1 millimeter calculates out to. 1.039. And if I'm at 0.124 minus 0.087, that's 37 thou, and 1 millimeter in inches is 39. So that's within 2 thou. I would say one tells us we need to take off 39 thou, one's 37. We're going to split the difference on what I'm getting off of those two scales on the caliper, and we're going to take 38 thousandths of an inch off of this, and we'll be done. Yeah, we didn't leave a whole lot of extra spare on that, did we? Not a whole lot of extra to spare. All right, well that's good. Let's get this in here. We'll take off our 38 thou. We'll do that in one nice heavy cut to try to get a good finish on that. And we'll be ready to take it over to the mill. And then we'll be bringing it back over here just to get it knurled. We're doing this one-shot deal. I did one touch off, I zeroed it, and now I'm going over here and I'm just making sure that's good. So right now I'm at 1 thou and I'm still not touching, so I know I'm for sure within 1 thou. Perfect. All right, I got within 2/10, and when I got within 2/10, I was just barely touching. So now I know I've got just a nice, good touch off. We're gonna go our 38 thou in, and we're gonna take our cut, and we will have this set to length, and that will be our part done and ready to go. And we are just barely gonna break the edge on this, because this is what we're lining up our tool bit to. So we do not want to break this edge and put a big heavy bevel on there. That'll make it harder to line up with our tool. So I'm just barely gonna touch it with some emery cloth, make sure there's nothing sharp on it, but we're not going to put a big bevel on this one. That cap's going to be on there to keep that covered up. And there we go. All right, I'm going to be grabbing onto, let's see, yes, I'll be grabbing onto this end when we knurl it. So I'm going to go ahead and polish that up a little bit right now as well while we've got it here. And that should be it. We'll head over to the mill and we'll get that step cut in there. But first we'll get this cap machined off on the back side. We'll get it finished up and ready. Great tool for the job here. Alright, well a little bit of it's the rough surface from our parting tool, so we will call that good. Alright, same thing, we're going to take about 25 thou off this. Let's clean that up a little bit. And just like the other one, we're just going to break that corner with some emery cloth, and we will leave that a nice sharp edge to go up against checking our tools. And there we go. That is done. Deburred, drilled, counterbore. Screw head is going to drop down in there nicely. We'll get that onto our other piece. Go give that just a quick rub. Just to barely see a little bit of jaw marks in there. We can rub those out a little bit by hand, I think, and we'll have those all set. All right, so something we want to think about here as we're about to go over to the mill is when this is notched out, I want to have that cap swing from over here so that when I'm on this side, I've got good access to the edge of my piece with the cap swung out of the way. If I've got a boring bar, I can get over here. If I'm coming in from this side, I can get over here. So I want to make sure that when we put this in the mill, we want that way, which means we're looking to get rid of material right in here. So that's going to be set up in the mill. That's going to be right at 90 degrees is where we want to try to get that hole set up. So make sure we make note of that. And we also need to finish tapping this hole down in there the rest of the way. So let's go run over to the vise and let's finish tapping that really quick before we go put this in the mill. Gonna be close. Let's see if that got us in there far enough. We may have to shorten this screw a little bit, but between the washer and we'll see if that gave us enough. Let me go blow some chips out of here and we'll make sure we bottom that out. There we go. There, they're machined together, so beautiful fit on there. I've got a lock washer in there, so just enough to put a little bit of pressure on that. So really nice friction fit to spin that out of the way. Use that as our height gauge. I am happy with that. So there we go. Counter bore complete, lined up. Let's get this in the mill and get our flat cut on here. All right, so we got our red part marked off there where we want to cut. So I want to get this hole on the backside here as close to 90 degrees as I can. So I'm going to put my level across the middle of the hole, middle of the piece. I think that's pretty good. All right, I'm going to use a 5/8 insert end mill, Indexible end mill to rough that out. We're going to go 1/2 inch deep and 1 3/8 of an inch back. So we'll rough that to within about 5 thou at the bottom and about 5 thou on the back here. And then I'll change it out to a 3/8 end mill, and then we'll go in and we'll clean all that off and make it look nice and shiny and pretty. So this is a Glacern Machine Tools Indexible End Mill on here. You can probably see I've got their vise on here too, but yeah, I've been very happy with some of their tooling. Really does a nice job. All right, we're touched off there, so that's where we're gonna start our 1/2 inch deep from. We'll do 2 cuts of 250 thou each. All right, there's 250. Let's touch off on the end. We'll know where we're going for our 1 3/8. Well, I think my handle got in the way on that last cut. Might have cut some of it off. It's all right, we got that roughed out. So you can see there's just a little bit of a step back there. So I'm going to put a 3/8 end mill on there, and we'll go in and we will just take a skim. We're going to take about 5 thou off the bottom, and we're going to take 5 thou off the back and just clean all of that up in there. All right, so I'm going to go in there, I'm going to touch off on depth, and because this end mill is 3/8, my other one was 5/8, I just need to adjust it by 1/8 of an inch, and I should end up right back on my start point again. So let's actually do that first. If I come over here to 125 and re-zero that, now I should be right flush on the end of this again. And if I spin that, yeah, I've got a little burr turned up on it, but yes, I spin that and I'm lined up right on the end. So now I know where to measure off for my 1 3/8 of an inch deep. We'll touch off on the bottom, we'll set a cut for about 5 thou deep, and then we'll start working our way over in, we'll go with 350 thou increments, we'll work our way across. until we get right to our 1 3/8 depth back there. And it's only a 5 thou cut, so I'm just going to cut it both ways coming across. We're at a 5 thou cut. I'm not going to move any backlash or anything for climb milling, conventional milling, so we will cut both directions. And I'm actually going to start with a climb mill to try to get rid of this burr off the front edge. So we'll start with the climb mill, and then we'll go back and forth and zigzag our way across there. And there it is. Turned out nice. We got rid of that little bit of a step there on the backside from that roughing end mill, and worked out perfect. Just that last step was only 25 thou difference, so hey, it just looks like it stepped over there perfectly. We don't have a burr on the front, so we just barely touch that with the little file. We'll clean that up. We'll just touch the rest of this with a file, get rid of any little sharp edges, and we are ready to get this over there and set this back up in the forejaw and knurl it. Get our 3 inches of knurl on here, and project done. So let's head on back to the lathe. Well, before we get this set up to knurl, let's see how we're looking so far. So there's our step. We've got our flat on there. That fits up nicely onto our ways. And this is our tool bit that we had out that we used to set this up. And let's see how we're coming across there. And that is feeling very, very nice. That is looking good. I think what we designed and operational, and that's working. We'll put our cap on there after. We never did come back with our vernier caliper once we got that out to double check where we came out on our size. But if I put that across there, yeah, I mean, that comes out looking right at 180 millimeters right there. So as close as we can eyeball that on a vernier without having a 8-inch mic to check that, that is what we were looking to create. So I'm happy with that. That is going to work. All right, let's get this set up for our knurling. We'll get this all dialed in first, and then we're going to knurl. As I said, I just have this really cheap, what came with my CXA tool set. I do have some different rollers on there. Maybe that's going to need to be on my to make list one day, is to make a better knurling tool. But for right now, this is what we've got. So hopefully we can get a good knurl out of this. And we'll go ahead and get this set up square to start with. Well, we don't have anything in the chuck. We can get over there, make sure I've got this on here nice and square. That is on there nice and square. So that is good. All right, let's get that out of our way until we get this dialed up. I think that is good. All right, I've got that dialed in, centered up. I tend to knurl at pretty slow speed, so we're gonna spin this at 130 RPM. And we're gonna feed it at about 11 thou per revolution. So let's get our marks all the way around. Make sure we can see those. All right, so my technique for knurling is I try to push it in there lightly. I spin it by hand. And I try to get the pattern, I try to push enough pressure to get the pattern to jump into its own groove. Once it gets into its own groove on a full revolution, then you can continue to push and it will stay within its own groove. It'll basically pick up its own pitch on the way around. If you don't put enough pressure to get it to jump into its own groove, then that's where you start to split the knurl, and then once it splits and starts feeding, I don't know how to save it from that. So I tend to push enough pressure and try to get it where, again, it's going to come around on that revolution and jump into its own mark, and we'll see what we can do. So I've got this centered up. Both wheels should hit at the same time. Once it gets cutting, I'm going to put a little bit of oil on there, and we'll feed it across, push in a little more pressure, we'll feed it back, and we'll go back a couple times until we get the depth that we want. On this 4140, probably going to take a couple of passes to really get that to push all the way up to a full knurl for us. And as I said before, if I can't get it to not double knurl, if I can't get it to look good, then we'll take a skim, we'll machine it down to a slightly different diameter, and we've got some flexibility. We can just keep playing with the knurl until we get it looking the way we want to. So the goal is get a good looking knurl, not have it be exactly at this diameter. So we'll see if we can do it in one try, great. If not, hey, we'll make a couple tries at it until we get a good looking knurl on here. So I am liking the pattern on that, but it is It is not squared up enough, so I am going to go ahead and loosen this, and I need to turn it a little bit to get my knurl squared off. Even though it looked like I had that square, it is not making good contact. Well, we've got a nice looking pattern, but no, we're not. All right, I think that's better. Now I've got to get this to drop back into where I had it set up on here before. And as I push, it just wants to turn it away. So I didn't tighten that up enough. All right, let's try this again. Well, let's see what that's going to do for us. Okay, we're getting a nice pattern. It's not double knurling. That should be good. So it's looking pretty good. It's going to be a little bit light on that front end up on here. But let's get one more pass back and we'll get that just a little deeper. And it's just going to be just a little bit off crooked on this one where my tool wants to turn a little. It's looking not bad. Alright, that is a full knurl. Definitely what we're looking for there. Alright, so we didn't get a double knurl. Looks pretty good in most places except right there at the end. So, with trying not to totally mess it up, I'm going to try something here. I'm going to turn my tool post notable angle in that way. Now I'm going to see if I can get those to engage just off the tip a little bit and see if I can't get this to pick up where it was there. Alright, I think that's cutting in the same spot. I'm going to see if I can get that to clean up the front of this knurl a little bit here. Just using the toe of my tool to get that to clean up. It's looking awfully good. Just going to go a little bit deeper there to blend that in just a little more. And we'll just go one more pass forward and I think we've got it. That looks much better than where it was finished up before. There, a little bit of acetone in there to really clean that out. And we will call that done. Knurl looked all right. Sometimes too much light's a bad thing. But no, that looks good. All right, I'm going to do one last thing. I'm going to go put just a little cut on each side or each end of those just to really make that knurl pop. So let me get my tool post squared up here again. And I'm just going to go in here on each end of this knurl, and I'm just going to touch in here with a little bevel just to crisp up the ends of that a little bit. So I just want to go in there with this tool and just right on the ends of my knurl, I'm just going to go in probably about 20 or 30 thou just to make a really nice end of that knurl. I think that'll really make it pop nice there. My DRO turned on so that I can get the same depth on both sides. Just went in there 20 thou. Alright, so 20 thou on this end, left just a little bit of those lines that I'm trying to get rid of. So let me go in a little bit deeper to get rid of those. Alright, so if I go in 40 thou, there's just a smidge of them. I think we can emery those out or get those to buff off of there a little bit. So let me go back to this other side and go in 40 thou on this one. I'm going to grab a little bit of emery and just touch that to try to get rid of that little line. That makes our knurl look a little more finished. And then we'll buff up this end a little bit too to make it match since we polished that end already. And we should be done. And that is it. Alright, let's get this out of here. Get our cap screwed on. And that is another project complete. Happy with how that turned out. Alright, let's get our cap put on there. And there it is. Nice slide there with that lock washer. Good fit all around. Good grip. Shouldn't have to drop that on the lathe. And we've got a nice soft bottom where that's going to make contact with the ways on there and not be banging a piece of hard 4140 into those precision ways all the time. Before we wrap up, let's show this finished product in operation. So there it is. We'll show with a couple of different tools. So if I put a tool on this way, I can spin that out of the way there. I can get right onto the front of this. And I can see that I'm just a hair low with that tool. All the way around over the top, yep. So you can see where that gets off to the side. So I easily come over the top of that one. So that one's just set up a hair low. Get on something like this. And I can back that up a little bit. Right up in there. And that one is just catching on that top edge. So that one is maybe just a hair high. Get in with something like this tool. Feed over. That's right on the money. Let's see, let's try one of our boring bars. So get something on here on the back side. And we design this so that it moves out of the way when it's up here flush. And yeah, see, I can clearly see I've got that boring bar. It's more lined up in the middle. So the boring bar is just, that one's just a little bit low. So this is going to be good. Some of these tools, I set them up really quick a while ago and I never go back and check them out. Yeah, this one is clearly set up high. So I will be able to go through and set my tools up a lot more consistently with this as I am using them. And man, it sure just fits on there nice. Great addition to the lathe. Well, YouTube, that is complete for another project here in the Blades to Be shop. We've got our tool height gauge for this PM 1440 TL lathe. Hope you enjoyed the project. As always, it's not just about the project that we made, but it's the processes, the steps we learned on the way. So today we really talked about order of operations to make sure that we didn't end up with a center hole in the top of this, made sure that we weren't crushing our knurl in the vise or in lathe jaws along the way. So really thinking through order of operations for any project. Also had a chance to use that dead center to dial in this off-center hole right here. So anytime you have to do an off-center bore in something, or you're trying to make like something operate like a cam, you may need to do an off-center bore. That dead center is a great way to dial that in. So again, even if you never make a tool height gauge for your PM 1440 TL lathe, there should be some good learning in this project and some good steps along the way that you can use somewhere else. Knurling, some other things like that that maybe we don't do too often, turning a thread up to a big shoulder. So that's what it's all about. Hope you did enjoy this project. Hope you enjoyed some of those steps along the way. And as always, appreciate you watching the videos. Hope you like the channel. If you do, go ahead, hit that subscribe button, ring the bell. You'll know when the next video is coming out. Trying to get them out for you every week. Typically by 7 a.m. on Saturday morning, sometimes even getting them out on Friday night for that early preview. Not quite sure what I've got on board for the next video, but I will be thinking of something before next week. And I think I've got one customer project coming in, piece of angle iron with some slots in it, so hopefully we'll have that one in here in time, and that may be the next project we get out. But as always, until next time, I hope you're out in your own shop making some chips of your own, working on some projects of your own, keeping your tools sharp, keeping your mind sharper, and until next time, you take care.